Hi everyone, we're going over lecture number 1 today, which is the Introduction to Electric Circuits. Today we'll be talking about systems of units, electric charge, current, voltage, power and energy, and circuit elements. So basically a circuit is a combination of circuit elements that are interconnected. Circuit elements can be consisting of resistors, capacitors, inductors, and even antennas, transistors, and power sources. A circuit can be made of two elements or more. Now there are units that we'll be using throughout the course, and it's very important for us to know what these units are. We will be using the SI units, and we will be attaching prefixes to them that will be used to try to multiply or reduce their value. These SI units are attached in this table. I hope that you're familiar with them and can use them effectively. So charge is a basic unit, and usually it's measured in coulomb with the SI unit. It basically counts the number of electrons or positive charges, which is protons, that are present. The charge of a single electron is known, and it's given as 1.602 times 10 to the power negative 19 coulombs. And 1 coulomb is actually a very large amount of charges, which includes 6.24 times 10 to the power 18 electrons. Now, basically, as I mentioned, 1 coulomb is a very large amount of charge, so we will see mainly charges in terms of picocoulombs or nanocoulombs or microcoulombs. Even microcoulomb is a very large amount of charge. Charges will always be a multiple of electron charges. Please remember that charges cannot be destroyed or transferred or created. So the only way that would happen is through a nuclear reaction. So that is not considered in this case. So what is current? The movement of charges is referred to as current. Now, historically, we've always assumed that charges are moving from the positive side to the negative side. They always assume that, and for that reason, we still use that notation. However, we are aware now that it is actually electrons that move from that actually travel through wires. But still, we denote that in a circuit, we would have the current moving from the positive side to the negative side. It is also important to remember that a current is a measure that requires its direction to be mentioned. So we always have to note the direction of the current. Giving the value of the current is not sufficient. So a current is measured as basically the movement of charges with respect to changes in time. So basically 1 ampere is 1 coulomb of charge that is moving per second. In mathematical terms, we would denote I as dq divided by dt. Now as we discussed in class, we will have 2 forms of current. We will have direct current or alternating current. Direct current is a current that does not change with time, and alternating current is one that actually does change with time and follows a sinusoidal characteristic. So we discussed that, for example, batteries provide direct current, solar panels provide direct currents, and the main power that is used at the outlets is alternating current. So the sign of the current indicates the direction in which the charges are moving based on a predefined direction that was selected. So basically you first define a pre-selected direction, and based on that you would have a positive current or negative current. The following example makes this clearer. So if we look at figure number A, if we say we have 5 amps of current that is moving in the direction of the arrow, then the current is moving in that direction. However, if we want to show that, one other way is to set a reference to be pointing down and then say negative 5 amps is moving through that piece of wire. In that case, we know that the direction of the current again is upward because it's negative 5 amps, so the negative indicates that we're in the opposite direction of the reference set direction, and we are having 5 amps of current going in the opposite direction. So there are some solved problems that we will solve in class, and I will skip them, but we will move on to the concept of voltage. So when there is a difference in charge between 2 points, that's when the electrons travel from one point to another to try to make sure the difference is eliminated. This difference is expressed as a voltage difference potential. You can think of this as basically like a gravitational force. When you have a ball that is at a higher height, if that ball drops, it will travel down towards a point that is at a lower point. So a higher gravitational potential point and a lower gravitational potential point, and the ball basically travels from that higher potential point to the lower potential point and does some work and then rests. This is exactly the same thing when you have charges that are more at a point, and then you have a point that has a lesser amount of charges, then the electrons travel. Now, this creates the voltage or potential difference. So voltage is always going to require two locations to be referenced to. It is equivalent to the energy that is needed to move a unit charge between those two locations. Basically, positive charges move from a higher potential to a lower potential, and when that happens, they yield energy. When charges move from a negative potential to a positive potential, we need to actually spend energy, and that's, for example, the case when we actually charge a battery. So when we are dispersing energy from a battery, we have charges from the positive terminal going to the negative terminal. And when we're charging the battery, we're pushing charges into the positive terminal and out of the negative terminal. So please remember that voltage alone is not equivalent to power. Voltage is the potential to do work. It's exactly the same as having a ball that sits at a higher altitude or higher point. When the ball is sitting, it's actually not doing any work, so it's not exerting any power, it's just sitting at a higher potential. So you need moving charges, a moving ball, for example. If we use the gravitational metaphor, then you need the moving charges to actually exert power or generate power. So this requires the movement of the charges, and as we mentioned before, P is equal to V times I, is equal to the rate of energy provided or consumed per unit of time. So basically the unit of power, as we know, it's watts. So V times I, the potential times the current, gives you watts in terms of units. So conventionally, what we say is that an element that is being supplied with power is actually has positive power. So for example, a resistor that actually uses power has positive power, and an element that is actually generating power has got negative power. So a battery would always have negative power, and this is referred to as a passive sign convention. It's not so important, but basically if the I is moving into the positive terminal and coming out of the negative terminal, then you have a positive power because power is being consumed, and if power is being generating, the current is coming out of the positive terminal and is going into the negative terminal. So it is important to remember the conservation of energy. In a circuit, energy cannot be created or destroyed. So basically power is conserved. That means that if you have a battery that is generating power, then that power must be utilized or used by the resistors and other elements within the circuit. So the sum of all of the powers that are supplied must be absorbed by all the other elements that are in the circuit. Also remember that watts is joules per second. So if you multiply it by time, which has a unit of seconds, you get joules, which is the unit of energy. So generally speaking, the unit of energy is watts times seconds. Now you can use watts times time. Now you could use different units for time, and a general format that is used to try to, for example, sell electricity is based on kilowatt hours, which is the number of kilowatt hours that are used in an hour. So we'll solve some problems again in class, but let's move on to the circuit elements. There are two types of circuit elements. They're referred to as active elements and passive elements. Active elements can generate energy. Generators, batteries, or operational amplifiers are active circuit elements. Passive elements are the ones that absorb energy, and we can refer to as resistors, capacitors, and inductors. We do have to mention that only resistors are ideal at dissipating energy, because capacitors and inductors can actually store energy in them. So the other item that is important is an actual voltage source or power source. We have ideal voltage sources that we use, but there are also non-ideal sources. So in an ideal voltage source, we assume that the terminal can maintain its voltage no matter what current we draw from that source. In reality, they don't exist, but in the circuit side, we can make such an assumption. We also have an ideal current source. That means that for no matter what the resistance or what kind of element is introduced to the system, they will always force that specific current through their terminals. So for example, if you have a current source that has a total current of 2 amps, there will always be 2 amps being supplied from that current source. So based on that definition, both the ideal voltage source and current source can actually generate infinite power, but that is not necessarily true. So in reality, we have internal resistances within voltage sources, and we have limits on the total voltage that current sources can support. So basically, if you have a regular battery, if you short the two ends of the battery, what you will notice is that the voltage across the battery actually drops to 0. That's because of the internal resistance in there. And if you have a current source, which can be considered to be, for example, a transistor, then there is again going to be a voltage, maximum voltage that the current source can support. There is another set of sources that are important, and there are sometimes the students I've noticed have a lot of difficulty with them, are the dependent current and voltage sources. So basically the amount of voltage or current that they generate is dependent on some specific element within the circuit. Now we could have a voltage controlled voltage source, we can have a current controlled voltage source, we can have a voltage controlled current source, or a current controlled current source. It doesn't matter really what they are dependent on, but you can think of them as a voltage source that is dependent on another element within the circuit. So here is an example. For example, we have a current source here, a voltage source here, that its voltage is dependent on the amount of current that is moving through element C. So whatever current is flowing through element C will dictate the voltage around this dependent voltage source. And we will use nodal or mesh analysis to try to find the voltages and currents throughout the circuit. So dependent sources, I mean, you may ask, do we even have any sort of practical application for dependent sources? And yes, there are practical applications for those. For example, transistors. In certain modes of operation, the transistors can act as basically a current source. Because the amount of voltage or current within a specific element or within a specific element in the circuit will affect the amount of current that is flowing through the transistor infrastructure. Also, we can assume the same thing for operational amplifiers. We will go over them in details, but basically operational amplifier, you could use the input voltage to control the output voltage. So there will be like a voltage controlled voltage source. So we'll solve some problems, and I thought it would be important for us to go over a practical application of electric circuits in designing TV and CRT tubes. Yes, they're not being used anymore, but they had a great lifespan in designing TVs, oscilloscopes, and basically they work based on the idea of reflections and application of voltage sources, and we will discuss this in more details in class. With that, we bring to an end lecture number 1, and we will start lecture number 2 very soon. Thank you.